Hi, I'm Mr. Kangas, and today we're going to be taking a look at Chapter 6, Section 3, using proportions. And today in particular, we're going to be talking about how to solve a proportion when a piece of it is missing. So I would just like to clarify again that proportions are just simply two equal ratios. So when you're taking a look at questions 13 and beyond in Chapter 6, Section 3 on the practice sheet, you're going to be getting questions that may look similar to this. We have n over 12 equals 6 over 18. Now it's important to remember that you can represent a ratio as a fraction. It's typically the easiest form to work with them, but the proper way to represent them is with the colon between them. The only time we really use fractions to represent ratios is when we're working with ratios. But if I were to talk to someone about a ratio, I would want to talk to them and show them and write down a ratio using the colon, because the colon implies a ratio. Unless told that a fraction is a ratio, most people will not be able to deduce that or figure out that we are talking about ratios. If I just gave you a fraction, most people view that as 6/18ths, the fraction, not a 6/18 ratio. So if you're trying to communicate to someone about ratios, you typically talk to them about it and show them and write about it using the colon. So I just want to make that clear before we begin. But in this section, we're going to be solving problems that look like this. We want to know what goes on top. What is n? A what to 12 ratio is equal to a 6/18 ratio. How do you solve that? But before we get into that, I need to discuss some qualities about equivalent fractions or ratios. So the word equals, if you recall correctly from some previous videos, literally means that the same thing is on both sides. Not two things that look the same, but the same thing is on both sides. So for example, one example I use to get this point across is Mr. Kangas equals Justin Kangas. Okay? Justin and Mr. Kangas are not two different people that look alike. They are two different ways to talk about the same person. So whatever happens to Mr. Kangas happens to Justin Kangas because they're both the same exact person. So the idea here is that these ratios or fractions are the exact same ratio or fraction. So if I were to put up something that was a little more obviously equal, such as 3/4 and 3/4, okay, what you're going to notice is that when I cross multiply, when I do 3 times, when I multiply diagonally, I'm doing 3 times 4 this way, and I'm doing 3 times 4 this way. So I'm going to get the same answer when I cross multiply. When I multiply diagonally, I'm going to get the same answer from both multiplication problems. And that's going to occur no matter what two equivalent fractions I put up here. So for example, 2 times 3. 2 times 3. We do 5/8. 5 times 8, 5 times 8. Now, that's when you have this same exact fraction written the same exact way on both sides. This is also true if, for example, let's work with 1/2. Okay? 1 times 2 is 2, 1 times 2 is 2. Because these two fractions are exactly the same, and this is true that when I multiply diagonally, both multiplication problems get me the same answer. If I change this 1/2 to 2/4, okay, the same thing should still be happening. Okay, when I had 1/2 equals 1/2, and I multiplied diagonally, I got 2, and I got 2. So I got the same answer from both problems. I should still be getting the same answer when I multiply diagonally here. Even though I have two different looking fractions, these two fractions are equal. They are the same thing. They are no different than 1/2 and 1/2. 2/4 is equal to 1/2. They're one and the same, and they're like Mr. Kangas and Justin Kangas. So when I multiply diagonally, I should still get the same answer. I'm not necessarily going to get 2, but I should still get the same answer diagonally. Because since 1/2 is 1/2 and 1/2 is 2/4, whatever I can do here, I should also be able to do here. Okay, so if I can cross multiply and get the same answers with these two 1/2s, I should be able to do the same thing here, because 2/4 may look different, but it's still 1/2. Okay, so if it's true that when I cross multiply here and I get 2, and I cross multiply here and I get 2, then over here I should still be able to cross multiply and get the same answer here and here. So let's try it. 2 times 2 is 4, 1 times 4 is 4. Okay, so the numbers have changed. The fractions look different, but the fractions are exactly the same. So the same concept's still going to apply. I'm still going to be able to cross multiply no matter what the two fractions are, as long as they're equal. As long as these two fractions are equal, then when I cross multiply, I will get the same number with both. I will get the same number from both problems when I multiply both diagonals. So let's do a few more examples just to show you how that works. And I'm going to do them all with 1/2 just to keep things consistent. So if I do 2/4 equals 3/6, cross multiply. 2 times 6 is 12. 3 times 4 is 12. Okay, let's try another one. Let's do 5/10 equals 8/16. Okay, 8 times 10 is 80. 5 times 16 is also 80. And if you can't do math that quickly in your head, grab a calculator right now, do 5 times 16, and you'll see it gets you 80. Do 8 times 10, and it will get you 80. I can promise you that. So, with that concept understood, that when you cross multiply equivalent fractions, you get the same answer from both multiplication problems. When we go back to this, okay, same concept's going to apply. When I cross multiply, I should get the same answer. So when I do 6 times 12, I get 72, which should be equal to n times 18. Now I don't know what 18 times n is, but what I do know is that it is equal to 72. When I multiply this out, I should get 72, because when I have equivalent fractions or ratios, when I cross multiply, I get the same answer. So when I do 6 times 12, I should get the same answer as when I do n times 18. So now at this point, if you look at it, this looks very familiar. This is a one-step equation. I can figure out what n is by solving this one-step equation. So how do I solve it? Well, 18 is being multiplied. So to undo times 18, I will divide. So 72 divided by 18 is 4. Okay, so n is 4. So, and really, really, really important, this next piece. When you figure out what the missing piece is, ask yourself, does this make sense? You can actually check your answer right now. I can, since n is 4, I can replace this n with 4. So what I am saying is that 4/12 equals 6/18. At this point in time, you should take the time and the effort to reduce both of these fractions to see if they get you the same answer. Because if you did your work correctly, then when you reduce both of these, you should get the same answer. 4 and 12 are both divisible by 4. 4 goes into 4 once, goes into 12 3 times. So 4/12 reduced is 1/3. 6 actually goes into both 6 and 18. 6 goes into 6 once, goes into 18 3 times. Both of them got me 1/3. That means I did my work correctly. And I got the right answer. If this does not happen when you check your answer, you did something wrong. Okay? And that's really all there is to the second half of the worksheet. You're going to be doing a bunch of problems that look like this, following the same exact steps. You're going to cross multiply. The two answers you get should be equal to each other, and typically you will be left with a one-step equation to solve, and the answer to that one-step equation will be your missing piece, at which point you will need to check your answer. to make sure it's right. So, if there are any questions, please ask. And please, 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 if you are my student, check your answer. Take the time to check your answers, because if you get into the habit of doing that, you're going to be more likely to succeed. Because remember, if you don't do well on a quiz over a section, you have to go back and redo the section anyway. So don't make more work for yourself. Take the time to double check your work and do things right the first time around, and then there won't be a second time around. The next video will be on Chapter 6, Section 4, so tune in for that.